dear friends and viewers. Welcome back to my channel and Vinay Kumar Basics of Physics. Dear friends, in this video we are going to discuss about the finding the velocity of fluid which is falling from certain height by using Torricelli's experiment. This is the 4 marks question, most important 4 marks question. That should be in the chapter of mechanical properties of fluids, that is related to the intermediate first year physics. Dear students, if you want to get the knowledge about this topic, you have to watch the video till end. So the thing is here, what is Torricelli's experiment? Torricelli explained to find out the explain our activity to find out the velocity of efflux. What is mean by efflux? The fluid which is coming from a narrow hole or orifice, that is what we call efflux. Torricelli's experiment is nothing but application of Bernoulli's principle. Application of Bernoulli's principle. Look here now. So this is the arrangement of the experiment. This is the one container. In that, up to some height, this is the ground. From that ground up to here, now this is the bottom ground, and this is the top level of the water. That should be at the height of y2 from the tank bottom. And now here there is one orifice. Look here, this is the container, should be like this. This is the container, and it is a narrow orifice, a narrow hole. Here you have to take that up to this level, some water is there, and that should be having some height y2 from the bottom of the container, and this orifice is at the height of y1, at the height of y1. Clear? This is now here simply now y2 minus y1, that is the height, that is the height of the fluid above the water. So children, this is the top surface of the fluid. There is some gap, it is there, and from this orifice the fluid is falling like this. Clear? What we are going to identify here, y1 is at the height of, y1 is what? Height of the fluid from bottom to the orifice, and what is y2? Height of the liquid level from the bottom of the container. Clear? So y1, y2 are like that. Here this, here to here y2, and here to here is y1. Now this is what? y2 minus y1. What it is? y2 minus y1. That should be the height. So here, what is Bernoulli's principle? P plus rho gh plus of rho v square is equals to 0. Sum of pressure energy, potential energy, and kinetic energy is constant. P plus rho gh plus of rho v square is equals to constant. What is P? Pressure energy. What is rho gh? Potential energy. And what is rho v square? Kinetic energy. So dear students, now here I can inform what, right? P1 plus rho 1 gh1 plus of rho 1 v1 square is equals to P2 plus of rho 2 gh2 plus of rho 2 v2 square. This is the another form of Bernoulli's equation. Clear? Of rho 2 v2 square. Now we are going to here apply the same thing for Bernoulli's principle now here. So dear students, in the diagram children, we are taking this part is the second part, and here this is the first part. What is orifice? Like a side trap. So that should be having some area is A1 and this area is A2. Here some pressure is there, that is what I have to say, P2, and the pressure of the fluid that should be coming outside is what? P1. On that fluid, some atmospheric pressure is there, that's what, right? P1 is equals to PA. So that is how to know to explain the Torricelli's law. Clear? Simply what it is, y1, y2 are the heights of the water level from top level to the bottom is y2, and up to here orifice to the bottom what is y1, and above the orifice water level is y2 minus y, that is h. That is the first thing. And second thing is what? Above the water there is some empty space is there at that particular area A2. This area what you have to take, this is the A2. There is some pressure is there, that should be what you have to say P. And next here when the water is coming out from the orifice, pressure is P1, that should be applicable by the or implemented by the or by the atmosphere pressure. That is what P1 is equals to PA. Now for this situation you have to apply the Bernoulli's principle. So according to the Bernoulli's principle, what you have the equation? This is the equation. What it is? P1 plus rho 1 GH1 plus half rho 1 V1 square is equals to P2 plus rho 2 GH2 plus half rho 2 V2 square. That is the, here we are having the condition. So same thing, we have to apply the Bernoulli's principle for the two places. One is the top of the liquid, next one is the at the position of the orifice or side trap. So that's why here according to Bernoulli's principle, what to write here? The pressure at this one is what I have taken P2. What is P2? So like the same the formula you are going to use. Here simply I am going to write formula again. P1 plus rho 1 GH1 plus half rho 1 V1 square is equals to P2 plus rho 2 GH2 plus half rho V2 square. Rho 2 V2 square. In the same manner, here first we have to applicable here and here. So what is pressure there? P2 plus rho. Rho is what? Density of the liquid, what it is in the container. That is I am going to here rho 2 G. And here height means what? Here nothing but from bottom to the top one. What it is? Y2. Rho 2 G Y2 plus half rho 2 V2 square. V2 square. Here what is V2? Velocity of the liquid at this second position. And here now the velocity of the fluid at the orifice is V1. So here P2 means V2 is over. Now P1 plus rho 1 G H1 plus half rho 1 V1 square. Half rho 1 V1 square. So children, here you have to notice, we are taking same liquid. That's why there is no change in density. That's why rho 1 is equals to rho 2. At the same time, when the water is coming from the side trap or orifice, there is no movement of the fluid at the top level. The water which is in the surrounding of orifice, that only going to be disturbed. Clear? While the fluid is came out from the orifice, the top layer seems to be at rest. The water, what it is there, that should be disturbed at the orifice only. Here only some velocity changes, but there is no change in velocity at the top of the liquid. That's why here we will take V2 is equals to 0. So at the top of liquid, velocity is 0. That means we have to substitute V2 value is 0 in the above formula. Then what you are write? P2 plus rho 2 is equals to rho 1, and that should be what it is. We are going to take rho. Rho 2 means what? Rho, and G Y2 means here Y2 only, plus of rho into V2 value is what, children? 0 square is equals to again P1 plus rho 1 means what? Rho G. Here what is H1? Here. So simply H1 is nothing but here, which is the how much height is there? Y1 height. That's why here instead of H1, what we write, children? Y1. Rho Z Y1 plus half rho V1 square. Clear? So after that, here this term is going to be 0. Then what write? P2 plus rho G Y2 is equals to P1 plus rho G Y1 plus half rho V square or V1 square. So we have to bring the P1 to this side and this term also this side. Then what write? P2 minus P1 plus rho Z Y2 minus rho Z Y1 is equals to half rho V1 square. of rho v1 square, children. So now here again in that equation here what I have take here, rho z is the common, then what write, p2 minus p1 plus rho z of y2 minus y1 is equals to of rho v1 square. So children, what we are doing all these things, we want to find out the velocity of the fluid that is coming from the orifice. So that's why you have to bring it to and rho this side. Then what you get here? Children, we need some space, that's why I'm going to erase this one. So if you want to write the notes, just pause the video, and where you have to stop, there you have to stop and wrote the notes. Okay, look here now, children. If you can bring to this side, what right here? Simply what we have? 2 of P2 minus P1 plus again 2 of rho g of y1 minus y2. y1 minus y2. y2 minus y1. y2 minus y1 is equals to rho v1 square. Rho v1 square. Clear? So after that, here you have to take here now. Here 2 of P2 minus P1 of, if you can bring rho this side, what right? By rho plus 2 rho g of y2 minus y1 by rho into v1 square, children. So dear students, here already we discussed what it is, y2 minus y1. This is y2 and this is the y1. y2 minus what you are taken? H. Therefore here 2 of P2 minus P1 by rho plus 2 rho g h. 2 rho g h by rho is equals, here rho cancel, what you have, simply 2gh v1 square. Then what you get, children, here v1 square means what? Here that is v1 square value. Then what you have, v1 means what? Simply here 2 of P2 minus P1 by rho plus 2gh. So this is the expression for velocity. Expression for velocity on reaching the, here what it is, on reaching the ground. So dear students, here now what you have to say, P1 means what? Atmospheric pressure. Atmospheric pressure. Then what right here? P1 is equals to PA. And now let P2 is equals to P. Then what right? V1 is equals to under root of 2 of P minus PA by rho plus 2gh. So this is about the velocity on reaching the ground. So dear students, if P is equals to PA, that means what? When it is exposed to air, then what do you write? This term becomes is 0. Then P is equals to PA. Clear? When the top of the liquid is exposed to the air, then what right? V1 is equals to 2 of PA minus PA by rho plus 2gh. This term is going to becomes 0. Then what we get, children? V1 is equals to under of 2gh. So this is the expression for velocity on reaching the ground to the orifice. So this is what? Velocity of efflux. Velocity of efflux. So children, there is one similarity between the velocity of a freely falling body to this one. So in case of a freely falling body also, we will get the same equation, V is equal to root 2gh. Clear, children? So he was given comparison between the freely falling body to the efflux which is coming from the orifice. He was given comparison between these two. So children, this is simply about the what is the speed of the efflux by using Torricelli's theorem. So if you can understand this one, like, share, comment the video and subscribe our channel. My request is inform and share our channel to your friends also. Okay, thank you for watching.